Hey everybody, let's talk a little bit about cell potential and spontaneity and bringing electrochem into the realm of thermodynamics. So it turns out that anytime you have a positive cell potential, and this is the fun stuff for me, okay, anytime you have a positive cell potential, that means that the reaction is always going to happen. So when you look at batteries will always have a positive voltage, like a 9-volt battery. It's always going to be positive because that reaction that's going on inside the battery is going to be is always happening. So if that reaction is always happening, if it's always going to be a positive cell potential and it's always a spontaneous reaction, doesn't that mean that for this guy here, that delta G is always going to be negative? Yes, of course, because that's what it means. And so again, just for completeness, not because I'm trying to insult your intelligence, but if the cell potential is negative, that means that delta G is positive, that the reaction is not spontaneous. So we have to make sure that we keep that in mind as well. So that means that as goes delta G, the opposite goes for the cell potential. So there's a formula that relates this, okay? And that formula is this one right here, okay, where delta G gives free energy. N is the number of electrons transferred when you balance the reaction. And the cell potential is what's calculated when you do the cell equals the potential of the cell equals the potential of the cathode minus the potential of the anode. And F is Faraday's constant, okay, and it's this, and it's always going to be this, and I'm always going to give it to you. Okay, so here's an example right down here. This reaction I've used in the past. I showed you how to get the cell potential of this. I probably balanced this with electrons. So we have all our information. Okay, now from the balanced chemical reaction, really quickly, I'm going to just show you that it's 2Ag plus 2 electrons, because you have 2Ag, reacts to form Ag, 2Ag solid, okay, and then it's Cu reacts to form Cu2 plus 2 electrons. So when you're worrying how many electrons are being transferred, what I'm showing you is that in this case there are 2 electrons, because what we know is that these electrons that are going from here are the same 2 as that are being used up here. So we have 2 electrons. So in this case, N equals 2, and the cell potential here, which you can look up how to do, but I will tell you that the cell potential equals 0.46 volts. So if the cell potential is 0.46 volts, that means that we know that it's positive, so that means that delta G has to be negative. Okay, so now we plug this into this formula. So we get delta G. So the question is, determine what the delta G of this reaction is. The standard delta G equals, so negative 2 times Faraday's constant, 96,500, times the cell potential, 0.46 volts. And so delta G equals, and so now let's plug it in our calculator. Okay, I'll pull up my calculator here. Okay, Electrochem. Gotta love Electrochem. Cell potential. Okay, and so we get negative 2 times 96,500 times 46. Sorry, not 46. 0.46. And when we do that, we get negative 88,780, and that answer should be in joules. Okay, so that's in joules. So to get this in more standard kind of terms that we kind of understand, that is we move the decimal place over 1, 2, 3, and that's going to be equal to negative 88.8 kilojoules. Okay? So that's how you relate this to delta G, just using this pretty straightforward formula, and life is good.